Hello friends. When we hear the word NASA, the first thing that comes to our mind is space, astronauts, rockets, the moon, and Mars. But what if I tell you that NASA, the organization that landed humans on the moon, is also invested significantly in exploring something much closer to Earth, like the deep sea? Yes, you heard it right. The same organization that studies the farthest corner of the universe is now exploring the uncharted waters of its very own planet. Why on earth is NASA so interested in what lies beneath the surface of the ocean? What exactly do they hope to find? And most importantly, in how many ways can such exploration change our understanding of life on Earth and beyond? In order to appreciate why NASA is interested in the deep sea, one needs to recognize how surprisingly similar the ocean is to outer space. The deep ocean is probably one of the most extreme environments on Earth. Pitch black, immense pressure, and freezing cold. These conditions are remarkably similar to those found on certain celestial bodies, like Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn. Both of these icy moons are thought to possess oceans beneath their ice sheets. Scientists believe that life can be found in those oceans. NASA's logic is, if we understand how life persists in the extreme environments in Earth's deep sea, it will prepare us to expect life in similar conditions throughout the universe. As for instance, hydrothermal vents, cracks in the seafloor that release superheated water loaded with minerals. This entire ecosystem of life, from bacteria to giant tube worms, has prospered without sunlight. Learning from these unique systems throws a light on how living may look like out in space. NASA does not begin ocean exploration from here. So far, one of the best initiatives is the Subsea project, where it interacts with oceanographic organizations studying underwater environments as analogs for space missions. An example would be at the Loihi Seamount, which is this underwater volcano off the state of Hawaii, because it closely compares the conditions of Europa by knowing the chemical processes and microbial life there. NASA hopes to perfect its techniques in biosignatures, its term for signs of life on other planets. NASA also uses high-tech robotic technology for its underwater operations. One of the most interesting examples is BIUIE, a buoyant rover designed to crawl on the underside of ice sheets, mimicking the way it could one day explore Europa's icy crust. These technologies are essentially prototypes for future space missions. By testing them in Earth's oceans, NASA can improve their reliability and performance before deploying them millions of kilometers away. NASA's oceanographic research has led to the following intriguing findings. For example, by studying the hydrothermal vents, totally new kinds of microbes have been revealed, those which eat either methane or hydrogen sulfide, compounds ubiquitous in most the icy moons of our solar system. Among the latest achievements, there is one, discovery of extremophiles. It refers to microorganisms capable of existence in boiling water, very acidic mediums, and in several other extreme conditions. If such life can thrive on Earth, it is not too hard to imagine similar organisms elsewhere in the universe. Moreover, research into bioluminescent organisms in the deep sea led to the birth of new ideas for detection mechanisms of life in other planetary systems, even under dim light conditions. Use your imagination. For example, when fitted with sensors that pick up dimmer glows in an extraterrestrial creature, it broadens our outlook on the phenomenon of life on Earth, and more importantly, sets our focus on new techniques for its detection elsewhere. The work that NASA does in the deep sea is not looking for aliens. In fact, this work has a direct application to the planet and to humans on Earth. For example, marine ecosystems are essential to the health of the planet. This research informs us about where to make efforts at conservation and the potential impacts of climate change on marine life, which might be very similar to terrestrial ecosystems. Ocean exploration has also been of great use in mining and renewable energy industries. Underwater geothermal activity is one of the studies that helped NASA develop sustainable energy solutions. The deep sea is no easy place to explore. The pressure at the ocean's bottom crushes most equipment. The temperature and darkness make it impossible to collect data. However, NASA's design for durable space technology gives it an advantage. NASA will cooperate and expand its partnerships with other institutions that research marine environments in the coming decade. Projects like launching the Europa Clipper mission in the 2030s